Hello, my amiable students. In this lesson, we'll be looking at bearing in a topographic map. By the end of this lesson, you should be able to demonstrate by finding direction, bearings within a topographic map. And you should also be able to answer questions that are related to directions, bearing on a topographic map. Geographically, what is bearing? Bearing is the mathematical direction of one place from another, or the mathematical or angular direction of a place in relation to another. This direction can be gotten or worked out using a pair of divider, protractor, and magnetic compass. But where they are not readily available, one can make marks and take quadrants of the different angular areas within the circle to get the bearing. So let's now demonstrate and take some examples. Our first example will be finding true knots and magnetic knots. If you draw a circle or a plus within an area on a map, the straight line that is horizontal is regarded as angle 90, while the straight vertical line is regarded as 0 or 360, the true knot. So to get your magnetic knot, you need to make a bisection of the 0 and 90 to get your 45. Having done that, you bisect the 45 degrees with 22.5 degrees to now have your magnetic knot. The difference between the two is called the magnetic variation. So when looking for bearing of one place in relation to another, you have to draw a mark like a plus in the various towns you are looking for. Then you draw a straight line to the other town and check which angular distance or angular form or the angle that it will form. That will be your bearing. Second example is taking the bearing of Sofia from Kobe. That means our standpoint Kobe while we are looking for the bearing of Sofia. To do this, we mark both Sofia and Kobe. Then we draw a straight line from Kobe to Sofia. Both sides. Then we connect both sides together and we see that Sofia is within the first quadrant, which is within the 90 degrees east, and we now take or bisect the area towards Sofia. When we draw a straight line from our standpoint in Kobe to Sofia, we see that Sofia is within the first quadrant between magnetic knot and the true knot. Then we bisect the line going towards Sofia from 22.5, and we will now see that Sofia is degrees east of Kobe. Example 2. What is the bearing of Larry from Dakar? Our standpoint will be Dakar, and we will now draw a straight line from Dakar to Larry. Please let us remember to always draw the straight line or the markings on the settlement rather than the names of the settlement, because sometimes the names can be far from such settlement within a map. If we take the angular distance, we will now see that 90 degrees is our east, while Larry falls a little bit closer to 90. So what we do is we minus 8 degrees, that is between 0 and that area from 90. I will now see that Larry is 82 degrees from Dakar. Sometimes what we just need to observe is whether the angles are acute or the angles are obtuse. So if it falls within the first quadrant, we try to connect with a series of acute angles. The first acute angle before 90 should be 22.5, while with another 22.5 you have 45 degrees that bisect 90 degrees from the center. To find the bearing of Larry from Uvu, we have to make our marks like this. You mark Uvu. Let's use a black line. We mark Uvu and also mark Larry. Then we draw a straight line from Uvu to Larry like this. We draw a line straight to Larry. Then we see that Larry is between angle 90. We see that Larry is within angle 90 that is straight like this as 90 degrees, and this other line that is straight down as our 180 degrees. Since this line is an acute angle between 180 and where we have Larry, it will now be 180 minus 22.5 degrees. Let's see what that one will give to us. That will give us 157.5 degrees. 157.5 degrees southeast of Uvu. So we note these marks and continue with them. So if it is in the first quadrant, you can bisect or make an acute angle and remove from the others. Or you can make a line to bisect within 0 and 90. If you are taking the bearing from magnetic north, it is referred to as a magnetic bearing. If you are taking the bearing from the true north, it is called true bearing. But whichever one you are taking, you can convert to the other type of bearing by deducting the magnetic variation. So if your true bearing gives you 100 and the magnetic variation gives you 6, that means your magnetic bearing should be 94 degrees. Intervisibility is used to show all the points in an area or in the map that are visible to one another. So if you are on top of a mountain and you are looking at another mountain, somebody on that mountain can be able to see you and you can be able to see that person on that mountain. Then if you have a 3-point ridge, the 3-point ridge should be visible to one another. So there are points where you can be able to see to one end to another. So it's an end-to-end description path that is visible inside a map. So intervisible paths are encoded in forms that will make the relief feature to be head-to-head to one another in their contour interval or their contour height number. So places that are intervisible are considered using the relief pattern or relief features that are brown lines alone inside the map. Other things that are not considered or that can be overlooked when considering points that are intervisible are hydrological structures, vegetative patterns, human and sociocultural features. So when looking at intervisible points, all those are not taken into consideration. The only thing that you take into consideration are relief features, contour interval, spot heights, and trigonometric ratios inside the map. So points that are trig ratios, contour heights, contour point, and contour interval are considered. So what are points that are intervisible inside the map? I know by now you'll be guessing points that are intervisible. So these points are two highlands close together like mountain and plateau, plateau and plateau, or mountain and mountain. Either sides of a valley are intervisible. A concave slope is intervisible from the base to the top. A gentle slope, all its points are intervisible from the base to the top. The highland and the adjacent lowland are intervisible to one another. A knoll or an incebed and the adjacent lowlands are intervisible. The 3 points of a ridge or the 2 points of a ridge are intervisible. All points on a plain or a lowland are intervisible. Looking at your escarpment, the gentle side of that escarpment and the top is intervisible. From the top to the adjacent lowland of an escarpment is intervisible. All others are then non-intervisible points. But let's look at the main parts that are non-intervisible. A plateau that is blocked by a mountain and the lowland at the back of the mountain is not intervisible. A convex slope, the top and the base are not intervisible. A steep slope, the base and the top are not intervisible. Two sides of a lowland divided by a highland at the center are not intervisible. So these points that are intervisible, they help us to make inference in communication pattern. And when you draw your cross section, after drawing your cross section, it is pertinent that you know the relief types or relief features that you are drawing, and you also know the points that are intervisible and the points that are not intervisible after drawing your cross section. So cross profile helps us to know points that are intervisible on the map and areas that are not intervisible inside the map. So like we said before, intervisible points show points that you can see from one part to the other. So they are points that are visible from one point of view to another. So from your standpoint, if you can see another mountain, that means your standpoint and that mountain are intervisible, notwithstanding or not considering vegetation, drainage, human and sociocultural features. So the only thing that you take into consideration is relief features alone. We said before that it helps us to make inference on communication pattern and areas or elements that are relative to aspects, shelter and slopes. They help us to know the slope types and parts of the map that are sheltered. How do you determine points that are intervisible? You don't need to draw a cross profile for every relief pattern or features that you see in the map to determine intervisibility. You can determine some variables or some relief features by heart, like no. No is a rectangular conical hill that is isolated in the midst of lowlands or plain. A plateau is a uniform tabletop highland that slopes gently to the adjacent lowlands. A mountain is a steep-sided highland with a peak. Then conical tend to be gentle at all points and it's relatively not high. Then you also have to note some slopes by heart. A concave slope is a slope that starts gently at the base and becomes very steep going to the top, while a convex slope is a slope that starts out very steep at the base but gentle at the top. A gentle slope is a slope that is even at all its points from the base to the top. An escarpment is a highland that is steep on one side and gentle on the other side. So the steep slope make a deep slope that is very steep and known into the base and the top. Contours on a map that are very close together, compacted, they make a steep-sided highland or a very high land. Slopes that are well spaced, gentle in their form, they make a gentle slope. When you are looking at the map, just observe these small patterns or look at these patterns very well, they will help you to determine points that are intervisible. Then also note that as contours break out and become bent to make a valley and a slope, the U-shape or V-shaped structure of the contour is where a river flows through. So the river flows from the bent part to the open part of the valley. So in the V shape, it flows from the bottom of the V to the top that is opened. Then a gentle slope, all its points are intervisible to one another. So we also have points that are not intervisible in a map. Points that are not intervisible in a map are conveying slope, a plateau that divides two plains, or a lowland that has a highland at its center. So that highland in its center will now be dividing the plains and make it not to be intervisible. Intervisibility helps us to know what will be good or what will be the best option in communication lines. Then it also helps in drawing your cross section or knowing your type of plateaus, mountains that we have or highlands that we have.